So equations reduced to quadratics. Alright, examples. Solve the following. X to the power of 4, take away 5x squared, plus 4 is 0. Alright, so we're looking at that and it almost looks like a quadratic equation, doesn't it? Okay, it almost looks like a quadratic. So what we need to do is make a suitable substitution into there, okay, and make, go from there, sorry. So, if I write x to the power of 4 as x squared or squared minus 5x squared plus 4 is 0. Okay. And then the next step, pick a variable. I'm just going to pick y. Pick what you want. Okay, whatever letter you want. Equals whatever is going to be in the middle. Okay, because if you make that, if it's in this format and you make it in the middle without the coefficient, you'll be able to write this using a quadratic. So, let y equals x squared. Okay, so everywhere there's an x squared in the equation, I am going to write y. So this becomes y squared, take away 5y, plus 4 is 0. And now it's a quadratic, and now we can use our skills to solve. So how do I solve for the quadratic again? Good, two numbers multiplied to give 4, same two numbers add to give negative 5. What are they? Negative 4, negative 1. So y take away 4, y take away 1 is equal to 0. So that means y must equal 4, or y can equal 1. Okay, are we done? So what do we need to do now? Okay, so the original quadratic is x's. You've just solved what you've manipulated for y. So y equals x squared. That means, so y equals x squared implies that x squared equals 4 and x squared is equal to 1. And then you solve those two. Okay, so what's the solutions for x for this one? Plus or minus, don't forget your sign when you have the square root of a number. And this one, x squared equals 1, x must equal plus or minus 1. So in other words, this quadratic, this degree 4 polynomial has 4 roots. Meaning it crosses the x-axis 4 times. Okay, so we use our quadratic skills by making a suitable substitution and then have to do the extra step in solving for what you substituted for. B. X plus 1 to the power of 4, take away 6 outside of x plus 1 squared, plus 8 is 0. Okay, so it almost looks like a quadratic, if not because the highest degree is 4. However, if we make a suitable substitution, we can turn it into a quadratic. Okay, so in other words, x plus 1 or squared, x plus 1 squared or squared, take away 6 outside of x plus 1 squared plus 8 is 0. This is like your y squared, take away 6y plus 8 equals 0. Now you don't have to show that step. If you understand what the substitution is, just go and do that, okay? So let y equals x plus 1 or squared. Okay, so in other words, whatever the middle term is without the coefficient will be the substitution in the vast majority of your cases. Okay? So this becomes y squared take away 6y plus 8 is 0. Right, two numbers multiplied to give 8, same two numbers add to give negative 6. Good. Y take away 4. Y take away 2 is 0. So solve for y, and then you need to go back and make your substitution. So y is 4, y is 2. Right, so this will be 2, maybe 3 marks. If you get to this point, you get your first mark. Okay? So to get your full marks, you need to complete this question. So we made the substitution, y equals x plus 1 all squared. So that means x plus 1 all squared is 4. And x plus 1 all squared is 2. Couple ways you can do this now. Okay, so we can expand the left-hand side. Take the 4 over to the left, make it another quadratic, solve. Okay, and do likewise with here. Or what's my alternate method? Take the square root of both sides. Okay, so if I take the square root of both sides, the x plus 1 is going to be plus or minus 2. Remember, we can have both positive and negative solution. And x plus 1 can be plus or minus the square root of 2. Of course, square root of 2 is irrational. So, x is going to be negative 1 plus or minus 2. Okay, so move the positive 1 over to the other side. So x is going to be negative 1 plus or minus square root of 2. So negative 1 plus 2, which is 1. And negative 1 take away 2, negative 3. And we can't do any more with that one. Okay, because I can't simplify that any further, make it look nicer. Alright, so this one has 4 roots. Okay, so there's 4 points on the graph where it crosses the x-axis, and those 4 points are the solution because we set it equals 0. In there. Any questions? Is everyone following what's going on? Yep. Let's see. Alright, 9 to the power of x. Take away 10, lots of 3 to the power of x. Plus 9 is 0. Almost looks like a quadratic, doesn't it? The format of a quadratic. That's a 9. Alright, so I've told you that the substitution in the vast majority of cases will be the term without the coefficient. Okay, so if I let y equals 3 to the power of x. Now, how can I rewrite 9 to the power of x so that I can use that substitution? 3 times 3, okay, is 9. In other words, 3 squared, all to the power of x, take away 10 lots of 3 to the x, plus 9 is 0. And then using an index clause, 3x all squared, take away 10 lots of 3 to the x, plus 9 is 0. Alright, you don't have to show all these steps, it's just to help you with your understanding.
Wouldn't that be the power of 2x then?
Sorry?
Wouldn't that be to the power of 2x?
Yes, but because I'm multiplying any order I want. I don't think you can see.
It's like 3 squared to the power of x.
Wouldn't it be 2x?
So 3 squared to the x is equal to 3x. Well, squared, isn't it?
Yeah.
This is just mathematics. We're not going that far, right? Alright, so that means y squared, take away 10, y plus 9 is 0. Making that substitution. Alright, two numbers multiplied to give 9, same two numbers add to give negative 10. Y take away 9, y take away 1 is 0, so y is 9 and y is 1. Okay, so back to your original substitution, you need to finish off your question. So we stated that y is 3 to the power of x, so 3 to the power of x is 9 and 3 to the power of x is 1. Three to the power of what equals 9? 2. Okay, so in other words, 3 to the x, if we make it the same base, the powers must be equal. Okay, so I've already written 9 as 3 squared, so x is 2. Okay, 3 to the power of what equals 1? Okay, any number except for 0 to the power of 0 is equal to 1. 0 to the power of 0 is undefined.
Doesn't x equal 0 again?
Pardon?
Wouldn't x equal
Sorry,
0?
yep. Just testing it. Okay, so that only has 2 roots, and they're the 2 values that they cross on the horizontal axis. Okay, last one, then I'm done. We're done for the topic. D. Is everyone following what's happening? Everyone getting an idea of what's going on? Speak now, forever hold your peace. Alright, x plus 1 on x squared. Take away 5 of x plus 1 on x plus 6 equals 0. Okay, this is a quadratic now because the highest power of the term is 2, isn't it? And if I do a full expansion, I will find that the highest power is 2. Okay, the highest power inside the bracket is 1. Okay, so that when I square it, the highest power is still 2. Okay, so I could expand it right out and tidy it up and go from there. However, I'm suggesting that it will probably be easier to make the substitution. So let y equals, so let x plus 1 on x. That makes y squared, take away 5y plus 6 is 0. Two numbers multiplied to give positive 6, same two numbers add to give negative 5.
17.
Okay, if you get up to there, that's your first mark. This will probably be a 3-mark question. The rest of them are probably 2. Alright, so we let y is x plus 1 on x. So x plus 1 on x must equal 2. And x plus 1 on x must be 3. Oh, was it buzzer, was it? Did buzzer sound?
Yeah.
Yep. So whatever you did, you pushed buzzer.
I didn't do anything. The love is formal, maybe someone will be getting really formal.
Alright, back to this. So, what do I need to do now? And Robin and Michaela, hold your horses for a moment. The rest of you, what do I do?
I don't want to.
Pardon? But it wouldn't give you a variable. It will just give you 0 equals 0 at that point. Anybody else? Anybody? Anybody?
Hey, busting over there.
Just let us think.
Alright.
Times by x.
Times everything by x because we want to
Oh wow. Another quadratic.
remove the denominator. Okay?
Where we have to use the bloody quadratic formula. I don't want to.
I have 3 roots.
I don't want to.
Alright. X squared plus 1. Where's the fun maths bit? I just something complicate everything on them.
I don't want to do this. So much effort.
Hey, this is still easy compared to what you've been doing this morning.
But it's a lot of effort.
Alright. So, x squared, take away 2x plus 1 is 0. Two numbers multiplied to give 1, same two numbers add to give negative 2.
Negative 1 squared.
So x take away 1 squared is 0 because we've got the same root, so we can write it straight as a square. So technically, so just to finalise all steps, okay, take the square root of both sides. 0 is neither positive or negative. We don't have to show the plus minus when it's 0. Therefore x equals 1. Alright, so I need to multiply this by x squared plus 1 equals 3x. X squared take away 3x plus 1 is 0.
You can't, because you have to use the quadratic formula, and it's
Yeah, I
so
would
much
like-
effort.
I would do this.
There's so much effort. I don't want to.
Oh no.
You can't text your mummy to come and help you.
You didn't actually take
I'm actually texting my mum.
Alright, so x is, so we established that we need to use the quadratic formula because there's no integers for this particular solution. The two numbers multiplied to give 1, same two numbers add to give negative 3. Okay, so unless you go to fractions, at least you won't have any solution. Alright, so negative 3. Hang on, negative b plus or minus the discriminant. Okay, so we all remember that formula well. Alright, so negative 3 plus or minus negative 3 squared. Take away 4 times 1 over 2 times 1. So 3 plus or minus 9 take away 4 over 5 over 2, so 9 take away 4 is 5. 3 plus or minus root 5 and 2. Was that really that much effort?
It's 3 roots.
Hey?
It's 3 roots.
Yeah. Yeah.
Oh my god. Nice work, sir. We just stopped it.
And an extra exercise for you two doing extension 1. How about you have a go at graphing all 4 of those equations?
Why is there 3 roots?
Because the mathematics worked it out that it is true. Right?
To the power of 2.
Have to get rid of that free somehow.
Alright, so that's now exercise 10.6, and that finishes the theory for this topic.